All right, welcome Earth Science. Today we are going to talk about mineral groups. There are over 3,800 mineral groups that have been named, and there's lots more that are coming each year, but we're only going to get the ones that are the most abundant and therefore the most important in our class. Common minerals, together with thousands of others that form on Earth, can be classified into groups based on their composition. So our mineral groups are going to talk about the composition or the elements that our minerals are composed of. Today's setup is going to be Cornell notes. So we've got our title up here of our notes, mineral groups. And then we've got questions and keywords down the sides and notes going on the right. Our first group today is the silicates group. It's composed of silicon and oxygen, and they're going to combine to form a silicon tetrahedron. So I know that that's a lot of new vocabulary for us today. Oh no. So our silicon is Si, and it's going to have 4 valence electrons. Remember this from Lewis dot structure. So it can make 4 bonds. And it's going to bond all 4 of these times with oxygen. So it's going to share valence electrons with oxygen here, and they're going to bond. So we'll get a tetrahedron, or 4 oxygens surrounding this silicon, and each one will share a pair of electrons. They sometimes also can have other elements, and these ones are very, very hard. If you notice from, or recall from lecture on Friday, quartz feldspar are some of the most common ones. Feldspar actually covering 60% of the Earth, and olivine are all examples. And they form mainly from when magma cools. So our magma can cool underneath the ground, or it can cool above ground. So if we're cooling underneath the ground, it's going to cool really fast. That's going to give us minerals like quartz. And if we're cooling underground, the temperature is going to be higher, and it's going to take a long time to cool, and that's going to give us some like these olivine right here. Our next mineral group is going to be the carbonates. Carbonates, just like it sounds, contain carbon, and they're going to be the second most common group. So our first most common group up here is the silicates. That's what makes up most of the minerals on Earth, hence it has feldspar in it. They can contain carbon, oxygen, and 1 metallic element, so iron, gold, copper, nickel, something like that. Calcite right here is a good example of this. This is the one in the lab, that number 1 that we dropped our acid on. Dolomite is also another one. And then right here we have some limestone and marble. These are examples of rocks that have these carbonate minerals in them. So these are all going to perform very similarly with the hydrochloric acid test. Limestone and marble, you could expect to see the same kind of reactions. Our next group is our oxides. Oxides contain oxygen and 1 or other element, which is usually a metal. They form from magma or heat or pressure or contact with air. If you look at this one right here, this is hematite. Hematite forms when it comes in contact with air, and it's got this nice rusty red color. These are all rusty looking. Our next group is our sulfates and our sulfides. Just like the name would suggest, they contain sulfur. They usually form from precipitation, which is when water is evaporating, or our hydrothermal solutions like Glenwood Hot Springs or Pagosa Springs. Galena right here is a good example, and is pyrite. These ones would perform the same as 2 and 4 on our acid test from our lab this week because they contain that sulfur. So with the acid test, whenever it contains the sulfur, it's going to smell. Halides. Halide is going to be a halogen ion plus 1 or more elements. So couple words we don't really or haven't really talked about in here is halides. So our halides are going to be this row right here on the periodic table 7A, which includes fluorine, chlorine, bromine, iodine, and 1 other element. And an ion just means it's going to have a negative charge. So this right here Halite is an example. This is basically just your table salt. So on the periodic table, it's going to be Na, which is sodium, plus Cl, which is chlorine and is in that halide row on the periodic table. And our native elements is the last group we're going to talk about today. Native elements, gold, copper, sulfur, carbon, just anything that's basically plain by itself. It's only one atom, only one element, and that's all that it's composed of. Please don't forget today to do your 3 to 5 sentence summary and or your haiku. Thank you very much, and I hope you enjoyed. Have a great weekend.